Okay, today we're looking at yet another differentiation method. Last time we did chain rule, this time we're using product rule. So when is product rule going to be used in mathematics? When basically for differentiation, when you've got two things that are multiplied together. So you can see the example there, y equals 3x sine x. That's the one we're going to be differentiating here. 3x is being multiplied to sine x. Both of these things you should individually be able to differentiate. Um, but when you're multiplying them, a whole different kettle of fish. Okay, so let's have a look at how this works. I've given the formula as u dash v plus v dash u, which is quite unusual. Other teachers will teach that in a different way. I have a reason for that. It works well when I teach you quotient rule, and it also works well when I teach you integration by parts. If you follow me on this, I think my method is the best method. That's why I go with it. What do you do first of all? You break down your function y, the one you want to differentiate, into two separate parts, u and v. Each part differentiate. So we decided that u is 3x, so u dashed is 3. We decided that v is sine x, so v dashed is cos x. Then just plug it into the formula. It's pretty damn simple. U dashed v would be 3 times sine x, v dashed u would be cos x times 3x, and also I'll move it as 3x cos x. Now, that seems pretty simple, and it's like we're 1.5 minutes in, and there's like, what's left? Obviously, this could be used with chain rule as well, in that you might get a function where one of the u and the v don't integrate that easily. So for example, sine, this wasn't sine x, it was sine 3x. That's fair enough. You're allowed to use chain rule and product rule together. And that's about, as far as I can see, the only thing you really need to know in terms of basics of this. A lot of this stuff is just about practice. So the formula is u dash v plus v dash u. Get in the habit of thinking about u's and v's because we've been using them a hell of a lot. That's all.